All right, so now you have chromium. So a lot of research has been done in terms of chromium and insulin sensitivity. All right, so I'll walk you through this diagram. Okay, so basically, chromium deficiency is sometimes noted in a diabetic individual, or else if a diabetic individual, just because of dietary reasons and so on and so forth, has chromium deficiency, these individuals are then supplemented with chromium. Okay, so now what is the role of chromium? So this is just the normal thing. So when you have glucose in the blood, these are the glucose channels, meaning they are like gates. Okay, these gates open. Okay, these gates will open, and then you have glucose enter into the cell. When will these gates open? Okay, when will these glucose channel or glucose gate open? When you have the insulin, this diamond shape is the insulin. When it is when it is combined with the insulin receptor, so this V-shaped thing over here is the insulin receptor, and then you have this chromodulin. Okay, so chromodulin is a type of a protein. All right. So now what happens is that when the cell senses that there is glucose and I need to take up glucose, you have insulin which will get bound to the insulin receptor. Your glucose channels will open. Okay, and you will have some amount of glucose come in. Now, what is the role of chromium? Okay, when you have sufficient amount of chromium in your body, all right, when the chromium senses, oh, the insulin is bound to insulin receptor. Okay, let me make this binding time much more longer and stronger, so that all the glucose, the required amount of glucose is what I'm talking about. The required amount of glucose then enters the cell sufficiently. So you have the chromium which enters the blood. When you have glucose start entering into the cell, this is when the chromium uptake from the blood is triggered. So you need to have enough amount of chromium in your blood to be taken up in your cell. Does that make sense? So that's why you don't want chromium deficiency. Okay. So when your cell starts taking glucose, the cell will say, let me take up chromium also, because it will help me to take up as much glucose as I want. Because if the insulin receptor complex separates, then the channels will close and I cannot take up as much glucose as I need. All right. So yes, your chromium will enter into the cell from the blood. Okay, now your chromium will attach to the chromodulin. Okay, and now this chromium chromodulin complex will then attach to the insulin receptor complex. Okay, so this is what chromium does. Chromium helps you to attach these things. Okay, chromium chromodulin complex to the insulin receptor complex. Now the channels will, now this channels will be open for a longer time, sufficient time for the required amount of glucose to be taken up from the blood into the cells. Okay, so basically this is the role of chromium. It creates a stronger complex between the insulin and insulin receptor. Okay, and for a longer time as needed by the cell. All right, so once the cell has sufficient amount of glucose and the cell needs no more, oh sorry, I should have gone like this. I finally just went to this. So yeah, chromium attaches to the chromodulin. Okay, so this is A, B, C. I directly just verbally said it and I didn't show you the diagram. So A, B, C, C is chromium chromodulin, and this complex then attaches to the insulin receptor. All right, and then you have sufficient amount of glucose taken in. Once you have sufficient amount of glucose taken in, this chromium is then released back into the blood, and this chromium is then eliminated from the body in the urine. Okay, and this is dose dependent. If your cells need more amount of glucose, more amount of chromium will be taken into the cell. Then you will have more amount of chromium usage, and then this chromium will be thrown out of the cell into your urine and excreted from your urine. Okay, so you will have high chromium levels in the urine. Okay, if it's been used like this. All right, so the problem happens in a diabetic individual when they don't have sufficient amount of chromium in their blood. If they have chromium deficiency, the body in a diabetic individual may also try using a lot more chromium as compared to, say, a healthy individual, because in a healthy individual, the insulin receptor complex is naturally much more stronger. But as you know, in a diabetic individual, because of decreased insulin sensitivity, increased insulin resistance, the body has to work twice more harder to have this complex. Okay. efficient complex. Therefore, chromium helps to improve the efficiency of this complex. So the chromium usage has also seen to be higher in diabetic individuals. All right. If the usage is higher, definitely then you have the need is also higher. So if you see in the blood reports that the diabetic individual is suffering from chromium deficiency, certainly this should trigger and advise that individual may benefit from chromium supplements. Okay, but this is not your call to take. This is done as a more multidisciplinary team. Okay, this decision making. All right, so now you have magnesium. What is the role of magnesium in increasing insulin sensitivity? So again, this the way it is explained, see guys, when I have, if you see, I have drawn a lot of flow charts, all right, in my slides. And this is my practice, because if I were to just show you the research article and I tell you, okay, I'm just going to verbally explain this, you look at this research article and this is there in your exam, you will freak out. Because the way it is written in a research article is much more complex, and it may not be you may not be able to digest it that easily as it is when you have a visual diagram in front of you. So that's why the use of a lot of flow charts, and therefore encouraging you to write your answers in exams in terms of flow chart and bullet points, to keep it simple, to come to the point, to make it easier for you. Okay, so at the end, remember guys, paragraphs are not going to give you marks. Science is going to give you marks. As long as you have the content right, even if it is written in a flow chart, that's going to give you a mark. All right. So that's the kind of person I am. I don't look at 4 pages of answer. I look at, does she have the sciences right, or does he have the sciences right? Okay. I'm more of a content person. All right. So yes, now coming to magnesium. So now what is the role of magnesium? All right. So now again, when you have glucose floating in the blood and your cell, the cell inside, the cell needs this glucose, what will it do? It will trigger magnesium from the blood to come into your cell. Okay, so again the condition applies. You should have sufficient amount of magnesium in your blood for it to be taken up in your cell. All right, so when the body senses that, oh, I am in need of glucose, when the cell senses that I am in need of glucose, let me take some glucose from the blood. So it will ask magnesium, magnesium come into the cell, magnesium will come into the cell. Now, when magnesium comes into the cell, 2 people go out of the cell, which are your calcium and your sodium. Okay, so this always happens. It's automatic. Okay, they flow in inverse direction. So when magnesium comes in the cell, sodium and calcium goes out of the cell. All right. And then when magnesium comes into the cell, then what happens? Okay, now this is important. So magnesium activates an enzyme which is called as tyrosine kinase. Okay, tyrosine kinase then further activates phosphate. Okay, now this phosphate makes the insulin receptor complex much more stronger. Okay, the same thing, it makes it stronger, and it helps the glucose channels to be open for a longer period of time. Okay, so because the glucose channels are open for a longer period of time, the glucose then can enter, sufficient amount of glucose can then enter into the cell. Okay, but magnesium therefore is so important because it is a very important nutrient, all right, to activate your tyrosine kinase. Okay, and tyrosine kinase in turn activates phosphate. Phosphate therefore makes the insulin receptor complex stronger. The gates are open for a longer time. Okay. So yes, magnesium, in summary, decreases insulin resistance. It increases insulin sensitivity. So now what happens when you have magnesium deficiency? Now remember, your blood always has to be maintained at a certain homeostatic level, meaning your body will say it is okay to have deficiency inside the cell, but I need to maintain an equilibrium in the blood. Okay, meaning the nutrients need to be at a balanced level in your blood. When the nutrients are less in your blood, they are already less in your cell, and there is no more that the body can take from the cell and throw in your blood. So for example, when you have iron deficiency, it means that your cells are already deprived of iron. There is no more iron that the cells can throw out into the blood for you to maintain your blood iron levels, and therefore now you are showing symptoms of iron deficiency anemia. just to show you the visual example of it. Okay, similarly, when you have magnesium deficiency, the body's first priority is to maintain blood levels of magnesium. Why is it so important to maintain nutrient levels in the blood, guys? It's a very simple concept. Remember, blood is the only thing which can flow all over in your body. Okay, so it can go into your brain, into your toes. Blood is the only fluid, the only compound which can travel. You don't have your stomach which is traveling all over your body, right? Blood is the only fluid which can flow all over your body. So yes, it is very important for us to maintain the nutrient levels in your blood well, all right, because that is the one which is flowing all over in your body. So in magnesium deficiency, what is happening? Yes, you have magnesium which is taken from the cell and it is thrown into the blood because our priority is to maintain blood magnesium levels first. Okay, you know, if magnesium goes out into the blood, the automatic response is for calcium and sodium to come into the cell. All right. So now when calcium comes into the cell, and when you have excessive amount of calcium coming into the cell, okay, remember, when you have excessive amount of calcium and sodium entering the cell, what does this cause? This causes vasoconstriction, all right? So it will narrow your blood vessels and this will increase your blood pressure, all right? Excessive amount of calcium into these cells, into the organelles, can result in calcification of your organs. Therefore, your organs are then they are not that viable, okay? They are not that soft and tangible, okay, because they are hardened now. So you have hard arteries, you have constricted arteries. This will increase your blood pressure. Okay, this is how you will see probably a diabetic. One of the reasons, there are many reasons, okay, one of the reasons why a diabetic individual may have high blood pressure, it could be because of magnesium deficiency, the electrolyte deficiency. Therefore, very important to check the blood levels of electrolytes in a diabetic individual. All right. So I hope this makes sense. These